Good morning, everyone. Welcome back. Week 6, day 1. Today we're going to start a new topic. So as you can see, I have over here 5 exercises. What is common in all of these 5 exercises? What can you say those exercises have in common, all of them?
That all the exercises they have the same variable in their problems.
Have the same variables? Well, this is X, and this is W, and this is Y.
In each one of one,
Okay, that each parenthesis has the same variable. Okay, very good. What else? What else can you notice on those exercises that are actually common in every single one? Like all of them have it in common.
They both have an coefficient and they both have an exponent with the exponent of one. A variable with one as its exponent.
Okay, that all of them have a variable with an exponent and a constant. Okay, what else? What are they? What are each of those exercises doing? What would be the operation of each exercise? Of every single one of them? What is the main operation in there? It's a multiplication, right? And I'm multiplying what times what? What am I multiplying? What are this? What are they? How are they called?
variables.
No, variables is this one. I'm talking about the whole thing.
The signs? Oh,
Yeah,
The whole thing. What is all of this called? What is all of that called? How are they called? What are they? They are binomials. And so this is the multiplication of binomials. And how are we going to multiply binomials? So we were working before with a monomial multiplying a polynomial. Now we're going to multiply a binomial times another binomial. So how are we going to do it? Exactly the same way. We're still going to work with rules of exponents, laws of signs, and distributive property. We're still going to work with that. Okay, so how are we going to do it? We're going to multiply the first term of the first parenthesis times everything inside the second parenthesis. Then we're going to multiply the second term of the first parenthesis times everything inside the second parenthesis. That method is called FOIL. FOIL stands for, I'm going to write it over here. FOIL stands for F of first. That's because you multiply the first times the outer times the inner. And then you do exactly the same thing with the last. And that's what FOIL means, okay? First, outer, inner, last. So we're going to multiply the first with the outer and the inner, and then the last with the outer and the inner. Okay, so we're going to do a distributive property separated in pieces. This can actually be multiplied in a different way that I'm going to show you after we solve it with FOIL, okay? So first, we're going to use FOIL. So we're going to do the multiplication exactly the same way that when we multiply a monomial times the polynomial. So x times x much is x times x? How much is x times x?
It cancels.
Multiplying, I'm not adding. How much is x times x? Exactly, Dana. Dana says that it is x to the second power. X times x is x to the second power. Now x times 1,
When
1x, or only x. Because remember coefficients ones, I don't need it. And there I finish multiplying the first term times everything inside the second parenthesis. Now I'm gonna do it in green, the second term times everything inside the second parenthesis. So 2 times x,
positive 2.
positive 2x. And the last one, 2 times 1, positive 2, correct. Now, every single time that you have a binomial multiplying another binomial, like in this case, okay, you will always, hear my words, you will always be having the middle terms as like terms, always, okay? So we're going to simplify that. We're going to say x to the square because that doesn't have no like term. How much is x plus 2x?
3x to the square.
No, I'm adding. I'm not multiplying. So I'm just adding. Remember the rule.
3x.
3x, exactly. Only when you multiply, you add the exponents. If you're adding, then you just go ahead and add the coefficients. Plus 2, because you didn't do nothing with the 2. You just did the middle terms, the word like terms. Now, whenever you have a multiplication between binomials, you will be having a trinomial as an answer. There is only one case that won't be a trinomial as an answer, but we're going to see that further on. Right now, notice that every single time that you have a binomial multiplying times a binomial, you multiply it using distributive property or FOIL, and you will get a 4-term polynomial in which the middle terms are like terms. So you simplify that and your final answer is going to be a trinomial. Are we clear with that? Yeah? Okay. Now, this is one method. I will be showing you another method, and you pick whichever method you want, okay? I'd rather be using the FOIL method because it is a little bit less complex, let's say. So what can you do? Well, having the same exercise, you can separate the first parenthesis and say x times, and you copy the second parenthesis, x plus 1. So you multiply a monomial times a polynomial. Then the first parenthesis has a plus 2. So plus 2, and you copy again the same first parenthesis. And then you do again the monomial multiplying a binomial. Now, why is this a little bit more complex? Because what if you had over here after the 2 something else, like, I don't know, like 3y, and I'm just making that up. Okay, if you had a 3y, so then you had to do again the plus 3y and copy again the first parenthesis. And if you had something else, another term, if it was a 4-term polynomial, let's say like y squared, then you will be having to do that same thing again. So you see your exercise becomes longer and longer as many terms it has. So it is easier to do just the FOIL method first and not this method, okay? So we're just gonna leave it like that as another example of how you can do it and have monomials multiplying the binomials, okay? So you're gonna just do it like that, and you're going to get exactly the same answer, okay? So x times x, x squared. X times 1, that will be x. Then the second parenthesis with the second monomial, it will be 2x, because 2 times x is 2x, and 2 times 1, it is 2. And as you can see, this is exactly the same as this, but it became an extra step. It had an extra step. So if you want to use this method, that's fine by me. But I would really appreciate it that you don't, that you learned this other method, the first one, because once that you get to 9th or 10th grade and you continue to see these topics, it will be longer and it will take a longer time for you to solve it. And remember, exams become also a little bit longer because the topics are a little bit more complex as you go further in your academic life, okay? So that's why I will be explaining the rest of the exercises with the FOIL method. Are we clear? Yep, no questions? Okie dokie then. Let's go with the second exercise, and we're still going to do it with FOIL method, okay? So we're gonna multiply the first term with the outer and the inner term, okay? And then we're gonna multiply the last term of the first parenthesis with the outer and the inner term of the second parenthesis. And we're just going to add over here a square, okay, and that's there. So we can see what happens when your exercises have variables as well. Now, we're gonna multiply. So we got W times W. How much is that? W times W?
W to the power of 2
Exactly.
or W to the square.
Very good. Both of them were the same thing. So very good. W squared. W times -5.
W, 5W, I think.
-5W. Okay, remember the sign. Don't forget about the signs. Signs are really important. And just for you to see, I'm placing it in green. -3 times W. -3 times
W is 3W.
-3 times.
Minus 3W.
-3W.
-3W.
And the last one, -3 times -5.
Negative 15.
No. -3 positive 15.
Positive.
Exactly.
Because negative times negative is positive.
Exactly. And which ones did I tell you were the like terms?
5W and 3W.
-5W and -3W. Don't forget the signs. Okay, so I copied the W squared. How much is -5W minus 3W?
Minus 8W.
Minus 8W or -8W. And I copied the 15. So right now we're just doing multiplications. There will be one time in 8th grade where I will be giving you the trinomial and you will be having to find the binomial. We're gonna go the other way around, okay? Obviously, we're gonna start refreshing our memory with the same thing of multiplication, and then we're gonna go and review the other way around, okay? Now, over here, this exercise has an exponent 2 in one of the binomials, okay? We have a binomial multiplying another binomial, but the second binomial has an exponent 2. Will that change my procedure? No, it won't change the procedure. It will only change the final answer. And let's see what's gonna change. So we're gonna multiply the first term with everything inside the second parenthesis, just like we did. And then the second term times everything inside the second parenthesis, just as we have been doing, okay? So y times y squared
Y cube.
Y to the cube. Y times positive 4,
Positive 4y.
Positive 4y.
positive 4y. Now we go with the second term. Negative 6 times y squared,
Negative 6 that y squared.
negative 6y squared. And negative 6 times positive 4,
Negative 20.
negative
20.
24. Okay, now I told you before that the two middle terms are always a like term. Is that true in this case? No, it's not. So
Yes,
it will
miss.
always be a like term when your variables have exactly the same exponent. In this case, the two middle terms are not like terms because this term have an exponent 1, invisible one. And this third term has a power 2. So they're not like terms. So what would be our final answer? Well, our final answer in here is this. However, for example, Iker, what's your second name?
Gael, miss.
That's your second name?
Yes.
Okay, and your last name is Garcia, right?
Fernandez.
No, your last name.
Fernandez. Iker Gael Garcia Fernandez.
Gael Garcia, yeah, Garcia. Okay, so is it the same thing if I call you Garcia Iker Gael as Iker Gael Garcia? It is not the same thing, right? Even though it is your name, it is not the same thing. It is not the same thing. My second name is Margarita. It's not the same thing if I say Margarita Lilian Vanegas. It is not the same thing. Well, because why? Because it has to have an order. So that's why we're going to have this written in a specific order. That's going to be called standard form. And standard form is when you write your polynomial starting with a term that has the greatest exponent and you go in a descending way. You go smaller and smaller and smaller and smaller all the way to your constant, okay? So we're gonna see which of these terms is a term with the greatest exponent. Well, it is this, y cubed. So I'm going to copy the y cubed first. Then what exponent goes after the 3? It will be exponent 2. So I'm going to copy the term that has the exponent 2. Okay, give me a second. So I wanted to have it there. So there, I'm copying the one that has an exponent 2, then the one that has an exponent 1, which is 4y, and lastly, the constant. And I always take into account the sign that's right on the left. And that would be my final answer. Did it change anything? Not really. You just changed the order so you can have it in standard form. And that's all that we did. Okay, but as you can see, I didn't simplify anything else. Okay, I just wrote it in standard form. So let's write over here that definition so you don't forget what a standard form is. So standard form, when we write a polynomial starting with the term that has the variable with the greatest exponent and continue in descendant form. Okay, so greatest to smallest, that's what it means. All the way until we finish with the constant. Okay, so this is one definition that we need to know. And you know now that it's not necessarily that you will be having a trinomial. You will be having a trinomial if and only if both binomials have exactly the same exponents, okay? Now, we began with a binomial that was just a variable with a constant. Now, as you can see over here, we escalated to a variable with an exponent. Now, we're going to escalate to a variable with a coefficient, okay? Now, that's what we're going to do, a variable with a coefficient. And afterwards, we're going to end with two variables that have exponents, okay? So I'm going to add those exponents over here that I didn't add at the beginning. The exponents too as well. So let's continue with this fourth exercise, okay? Now we're still going to do the FOIL method. I'm going to still continue to multiply the first term times everything inside the second parenthesis and the second term with everything inside the second parenthesis. Now we're going to multiply. How much is 2x times 3x? How much is 2x times 3x?
6x to the
5x.
6x to the what?
the square.
To the second power. Very good. How much is 2x times -1? Remember, we're multiplying right now.
Negative 2x.
-2x. And I finished with the first term. Now I go with the second term. And how much is 3 times 3x?
Negative 9x to the square.
How much is 3 times 3x?
Negative 9x.
Where is the negative coming from?
9x.
Because the both are positive.
Both of them are positive. So it is positive
Ah, yeah,
9x because positive times positive is positive. Now 3 times -1.
-3.
-3. And since both of them have the same variable, we can go ahead and say that they are like terms, the ones in the middle, right? So this is a like term with this. So I'm going to continue to simplify it. I copy the 6x squared because I'm doing nothing to that. How much is -2x plus 9x?
Plus 7x.
Positive 7x, very good. So positive 7x. And I copy the -3. And I'm telling you, one day you will be able to go from this trinomial all the way to these two binomials. Easy peasy breezy lemon squeezy right now. Okay, let's go with the very last one, which is 2x minus y squared times x plus 2y squared. So they appear to be the same, but they're not. And as now, as you can see, we have a variable and a second variable. Okay, we have different variables now in the same binomials. Will that change my procedure? No. Will it change the way that I write my answer? I don't know. Let's see. Okay, so let's multiply. As you can see, both x's are without exponents and both y's have an exponent. So let's see if we get a trinomial or we get a 4-term polynomial like in this special exercise. 2x times x.
2x to the square.
2x to the square. 2x times 2y squared.
4y squared.
Or
4xy squared.
4xy squared. Very good. Why am I writing that? Because they're different variables. So they're not like terms of variables, so I cannot multiply them. So I write them right next to each other, just like we did when we were multiplying monomials. Let's go with the other term. Negative y squared times x.
Negative y
Where
squared.
x
Negative y squared x, but we write it in alphabetical order, so it's negative x y squared. It's the same thing, but we're writing in alphabetical order. And the last one, negative y squared times 2y squared.
Negative 2y to the fourth power.
Very good. Negative 2y to the fourth power, because we have same variable in here, so we add the exponent. And as you can see, as I told you, since we have exactly the same variables with exactly the same exponents, middle terms are like terms, okay? So let's simplify them. So we got the 2x squared. How much is 4xy squared minus xy squared?
3xy squared.
Positive 3xy squared. And I copy the negative 2y to the fourth power, because I didn't do nothing to that one. And that is my final answer. Question, is this written in standard form? Yes or no? Yes, it's written in standard form, but maybe you might ask, but why, if you said that we start with a term that has the variable with the greatest exponent? Well, because we go alphabetically and x goes first in the y. So if you can see, the x is actually in standard form. Exponent 2, exponent 1, no variable with the of the variable x. And as you can see, it goes in standard form the other way around as well. The y starts with exponent 4, then it goes to exponent 2, and then no variable y. So it goes in standard form, but it goes the other way around, okay? So it doesn't matter how it's written, it is still in standard form because we begin with the variable in alphabetical order. Is there any questions so far? No? Let's place the topic's name. What is this topic's name?
Multiplying binomials.
Exactly, multiplying binomials, because that's all we did. Binomials. We multiplied a binomial
By FOIL.
using FOIL. We can place that, very good. Using FOIL. That's okay, we can place it because that's true. We multiplied a binomial using FOIL. Okay, so that would be today's topic. Questions so far? No questions? We're good? Okay then, this is today's topic.